So the next example is decoding a frequency modulated signal. This is not a riddle anymore, so we just have some more plain math here. So we have original signal here. So we have a low frequency signal connected with high frequency signal, and then connect to another low frequency signal, high frequency, and a low frequency signal. So I will assign my low frequency signal to be 0, because I want to decode it, and my high frequency signal to 1. So I have 0, 1, and then can you fill the middle? So I have 0, 1, 1, 0, 0. Yes, very good. So we assign all these numbers, and the decoded signal is 0, 1, 1, 0, 1, 0. Right? So you can use frequency as a way to code your signal. Okay, very good. So now I want you to send a code with the frequency. Okay, 0 is a low frequency, and 1 is a high frequency. Okay, so what does the first one look like? We'll show you first. So I have a low signal, low signal, low signal, high, high, high. Okay, I want one brave person to come in to draw the second one. So let me see. I have, this one's working. So who wants to come in and draw my second signal? We need a brave person. Come on, you're all teachers. You ask students to come to draw all the time. Now it's your turn. Yes, you're called. Should you receive this mission? Accept it or not? Oh, excellent. Okay, so high is a high frequency signal. So what you draw is some of these waveforms like this. I can help you to start with. Okay.
So I know this
you can do it.
Yeah, I'm looking at. So
right.
Is this soon to be? Did you break this up like a 0, 0, 1, 0, or negative 1, 0, 1, something like that?
Yeah, so you just copy this. This is 1, right? So you're going to draw a waveform as 2 times the frequency. So it's 1, is 0 will be low frequency.
Oh, you want a high? Okay, hold on. I gotta get my pictures together.
Right.
This is low.
This is 1.
Low,
this is 0, 0,
low,
0,
low,
1, 1, 1.
High. That's a high.
High, high, high.
High, high, high.
Right.
High.
So
oh
this is 1. It's
so
going to be high.
This, oh gosh. This is a high. It starts here.
Yes. Okay.
Go down. Somewhere there's a line in here.
You don't worry about the line.
Okay. So.
Okay. Just do the waveform. So. 2 types of frequency. This is only 1. Okay.
This is still low.
Still low. You have to go up again.
Wait a minute. This is still 1 because it's a low. High. I'm looking at.
Do it twice for a 1.
Twice.
Okay, twice.
Yeah.
Okay. Thank you.
Again, up. You have to go up. So you have to have this waveform.
So
this is 1. Okay. So this is 1.
This is a 1 because
okay.
It's here to here.
Right. And then you will do a 0.
A low.
Okay. Low will be stretch the signal.
Here to here. That's a low.
It's going to be longer.
Longer.
You want it longer?
So it's going to be wider.
Oh, wider. Not longer, but wider.
That's right.
You like that? Is that a good dip?
Something like that. Yeah. So you just repeat the waveform of that one. Right. Excellent.
Okay,
so you can do 1 again. Do the same one for the first one.
Okay. This is
1. Okay.
2, 1.
So you want them to be more narrow.
I
yeah.
know.
So the frequency. So thinking about from the frequency.
You need some grids here.
Yeah.
I'm sorry. I'm
yeah.
for
With
grid.
frequency. Oh yeah. With grids it will be a lot easier.
So this is this one. I'm starting at this tip. So this is here.
Good. So you have a waveform has twice the frequency.
Here.
Okay, up.
And here.
Excellent. So that's a high frequency.
This is high.
And you need a low frequency again because my fourth one
so
is
my
0.
Right here.
Low frequency.
It's
more stretched. Yes.
Is that stretched good?
That's pretty good. And then okay, so we have no room.
I have no room.
Yeah, basically she did correctly. We did 1, 0, 1, 0. So high frequency, low frequency, high frequency, low frequency. Very good. Yeah. So yeah, you need the repeat.
Right.
So it's the same, but you don't have room. So who can draw the third one?
Thank you.
Yeah, thank you. Thank you for your courage.
Since he volunteered me.
Excellent.
Popcorn.
Welcome. Okay, so let's do low frequency, low, low, 0, 0,
Now you need high.
and a 1, it's a high frequency. Very good, and then 0, 0, 1.
I have a question that I was gonna ask later, but
Yes.
maybe you can entertain this question too. So I wrote it down.
Very good.
Are we assuming that?
I
like, when we
confirm you did
send-
it correctly.
When we send codes and wavelengths, are they mimicking either the sine or cosine function? Is that the message behind this?
So I think it's more like the frequency. In terms of this, it's more frequency.
Right.
So you don't differentiate where the zeros start with.
Right.
It's like a
But
cosine or
it's like
sine.
shape-wise.
Yeah, it's more frequency-wise, right? So like high frequency is this omega 1, low frequency is omega 0. So when you receive the signal, you know the first signal was a high frequency signal, it will decode into 1, and the second is a low frequency signal, it will decode into 0.
Because when I'm thinking of like the sine and cosine, when I think of sine, I'm always thinking about.
You start from 0, yes, and
then when
cosine
I'm
you start
thinking
with 1.
With cosine, I'm thinking about it's a little bit more stretched out, a little bit.
Yeah, that's just, you have basically sine, cosine, just switch the, like shifting the x-axis,
Okay.
right? And
They both have the same basic shape.
they have the same
Yeah,
shape,
but
that's
one
right.
is kinda
Which
like a
mimics
little
a
bit
radio,
more-
which mimics, say, a radio wave.
Exactly.
A radio wave is gonna look like, you could say, oh, it looks like a sine.
Yes,
I said, no, it looks like cosine. Well, it looks,
Yeah.
they're the same shape.
they're the same shape, but one is
They
more
both have
stretched
a
and one is a little bit more
frequency.
condensed. Okay.
They both have a frequency. And by modulating the frequency, you get FM. Frequency modulation, FM.
Okay.
Yeah.
That was my
FM
question I wrote on top of
radio
my paper
waves
for
are
later.
sent by modulating the frequency.
Okay,
AM radio waves are sent by modulating.
And
the frequency.
amplitude,
okay.
yeah.
So they have a constant frequency. with-
Right, because we were
Changing
talking about heavy
amplitude.
low. Okay.
Right. So we are right now we are actually decoding the frequency in this case. So he did it correctly, and there are 2 waveforms behind the board, and I confirm it's right. Oh, I think that's it for all we have for now, and I think later.